afternoon, everyone. Again, my name is Robert Dodd, and I'm Product Manager over here at CleanEdison. Welcome to webinar number 4 of our May webinar series, Introduction to Geothermal. Just a couple preliminary things before we begin here. If you have any questions at all during the webinar, you have the ability to use the questions feature in your webinar box on the right side of your screen. We encourage you to type a question to us at any time during the presentation, as your audio controls are disabled. When we are finished, I'll direct the questions individually to the instructor, and we'll be able to answer whatever we have with the remaining time. Any additional questions can be forwarded to the contact information that will be on the last slide. So today's webinar will be presented by Peter Tavino, top CleanEdison Geothermal Instructor. And at this point, I'm going to turn the presentation over to Peter. Peter, take it away.
Thank you, Robert, and good afternoon, everyone. Thank you for giving us your Friday before the Memorial Day weekend. Let's go through the IGSPA accredited installer certification process and what's involved with attending these 3-day seminars to become certified. We'll start here with this drawing you all see. I hope you see this pinkish house here, and it's our typical diagram showing that water goes into the ground as a cool water and comes out warmer, and we take the heat out of the ground to heat the house this way, and in the summer we reverse it. And over to the right you can see a slinky loop horizontal field that has water circulating in those black plastic pipes. And what we do is we determine how much pipe, how deep, and everything we need to know to move this heat from the ground into our house. So let's start with it. When you take the course from me, you're going to be reading a lot of this yourself so that you're totally participating. But for this webinar, I'm going to read these 13 slides. So we'll start this way. The heating and cooling of any building is an energy-intensive process. In fact, heating and cooling account for about 56% of the energy use in a typical U.S. home, making it the largest energy expense for most homes. Geothermal heat pumps, GHPs, use the constant temperature of the earth as the exchange medium instead of the outside air temperature. The biggest benefit of GHPs is that they use 25% to 50% less electricity than conventional heating or cooling systems. According to the EPA, Environmental Protection Agency, geothermal heat pumps can reduce energy consumption and corresponding emissions up to 44% compared to air source heat pumps, and up to 72% compared to electric resistance heating with standard air conditioning equipment. There are several different types of geothermal heat pump systems available. Which one of these is best depends on the climate, soil conditions, available land, and local installation costs at the site. All of these approaches can be used for residential and commercial building applications. And the workshop does cover the simpler residential single-family home for beginning installers, but we do address commercial buildings as well. Now to the right we see in this slide another diagram. This diagram shows a vertical loop near the house, and you see that the water is circulating down into vertical bores. These would typically be 300 to 400 foot deep boreholes drilled by conventional well drilling equipment, well drilling rigs, by well drillers. You see that the water will circulate by reverse return, first in is last out, and we will be going through all of the manifolding and how to design these process systems. And inside the building, in the basement, you see a circulator pump and a heat pump there that draws the heat out of the ground into the house. There are some other types of systems available too. One is the horizontal loop, such as the one I'm looking at myself under my own front yard here, buried underneath my lawn, I have a horizontal loop, almost 800 feet long and about 7 feet deep, and that's how I heat and air condition my own house. There's also a slinky loop like the slide we saw before, where you can put a lot of pipe coiled up in a smaller area of ground. And there's also the pond loop option, where we could draw heat from pond water or lake water instead of the ground. Okay. So there are approximately 50,000 geothermal heat pumps installed in the United States each year. Knowing how to properly install a geothermal heat pump and the ground loop is rapidly becoming an extremely profitable skill set to possess. And here we see the red track excavator is digging the ditch that will connect the pipe into the basement of the house on the left and go out probably to a vertical bore system near this house that will take the heat out of this ground and bring it into that house. And in the summertime, it will take the heat that's in the house and reject it back into this ground. Through the International Ground Source Heat Pump Association Geothermal Installer Program, heating, ventilation, and air conditioning contractors, builders, plumbers, engineers, and business owners will learn both the fundamental theory and the practice of designing and installing ground source heat pumps. This 3-day course includes an open book exam to become an accredited geothermal installer, membership in IGSPA for 3 years, and hands-on heat fusion training. We have great success being sure that candidates that take this workshop do receive a grade over 90 out of 100 in the open book test so that they can have their 90% passing score and become certified. We focus heavily on what it takes to pass this test, as well as answering all questions about what it takes to install a geothermal system. All the CleanEdison trainers have a minimum of 5 years experience in the field, and IGSPA certifies trainers by their own program, so you can be sure that you're getting quality instruction. And I'm happy to say that I enjoy instructing, and I look forward to instructing you. Here's a case study about the Park Chase apartments. We'll be talking about single-family homes and commercial buildings and also housing complexes like this. Here's an example of geothermal in action. The Park Chase apartment complex consists of 64 buildings containing 348 apartments spread out over 27 acres. The U.S. Department of Housing and Urban Development, HUD, repossessed the struggling property in 1991 and began a series of cost and payback analyses for several different types of HVAC systems. They found that the GHP had the lowest operating cost and the lowest first costs. Since then, HUD has saved $60,000 per year in energy costs, even while occupancy rates have nearly doubled. In addition, the better reliability of the GHP system allowed the maintenance crew to work on the system once every few weeks instead of every day. So here's a basic course outline for the 3 days. We present PowerPoint slides of each of these chapters, and then we go through a study guide with sample questions and answers on each topic and proceed through the 7, 8, 9 lessons so that by the 3rd afternoon you are ready to take the exam. In the beginning, we have the introduction and overview, where we look at the basic heat pump system, system materials and components. You'll see to the right a sample system here where the water is going out cold and coming back in hot. So this would be the heating mode. And the temperature differential here is about 5 or 6 degrees. Believe it or not, water that's entering the house at 45 degrees and leaving the house at 40 or 39 degrees, that 6-degree differential divided by the gallons of water that are required are enough to provide the total heat that's needed for the building. In the second chapter, we discuss economics, marketing, and demand reduction, the benefits to homeowners, HVAC contractors, and utilities. We have a lot of information that geothermal systems perform and supply a short return on investment to those people wise enough to install it. Next, we select, size, and design the heat pump system. We go through a design procedure, usually the ACA-J you may be familiar with, that gives us how many BTUs per hour or tons per hour of heat are necessary, and we size our heat pump for a house as a 3-ton or a 4-ton or a 5-ton heat pump. And we go through all of these examples in this workshop. We do energy calculations to show what the annual heating and cooling loads and costs will be, and we discuss equipment selection and why we select heat pumps based on their heating capacity and cooling capacity. Then we design the ground heat exchanger. To the right, we see another example of a slinky loop. That is a ground heat exchanger. That's probably buried some 6 feet deep in that trench. Those are probably 4-foot diameter, 1.25 inch slinky pipes through which the water circulates and picks up the heat from the ground. So we show ground heat exchanger configurations, the plastic pipe selection, and we select the circulating pump for the loop. Pipe joining methods are important for this plastic pipe since it lasts almost forever because there's no metal in the ground. IGSPA requires certain fusion procedures, and the 3 that we look at are the butt fusion procedure, the sidewall or saddle fusion joining procedure, and socket fusion procedure. What we will do in the actual workshop is have some pipe and a heating iron and some T's or couplings, and we will actually perform some socket fusion together after thoroughly learning about it so that you can see yourself how it's done. Generally, a house can be served by a geothermal system that does not require any socket fusion, but if a commercial building and a larger field is installed, then we go through the fusion process. Also, when well drillers drill their boreholes, they generally heat fuse a 90-degree elbow about 4 feet underneath the grass surface and connect it into the house. So IGSPA emphasizes proper heat fusion procedure, and accredited geothermal installers get hands-on experience in this. Then last, we talk about the installation of the ground heat exchanger with a site plan. We talk about the installation equipment such as well drilling rigs or track excavators or chain trenchers or horizontal bore machines. And we look at the different trenching and drilling costs. After the loop is installed and the heat pump and circulator pump are installed in the basement, the inside of the house, we talk about flushing the air out, how important that is. And IGSPA has a wonderful video showing how we can flush the air and debris out of our loop system to be sure that there's only pure water going into the coaxial heat exchanger of the heat pump. We go through error detection techniques and how to charge the system with antifreeze solution. We also compare the propylene glycol biodegradable antifreeze to the methanol and ethyl alcohol and other types of antifreeze solutions that are out there. Then we have a heat pump system startup and checkout where we look at the heating mode and cooling mode operations, and we'll go through a verification of installed performance Excel worksheet so that you can see that the electricity being used by your heat pump is the small amount necessary to keep it very efficient. So in obtaining an ICSPA certification, you will be able to show a thorough understanding of ground source heat pump systems, what they are, where they should be implemented, how they can be enhanced, and why they're attractive to homeowners. So thank you for your interest in CleanEdison's ICSPA geothermal installer training. We look forward to seeing you in one of our upcoming courses. We currently have courses scheduled in locations across the country. For more information, please contact us at 888-513-3476. That's 888-513-3476. Or visit our website at www.cleanedison.com/geothermal.html. So that concludes our 13 slides, and I look forward, Robert, to hearing some of the questions from the folks in the audience.
Great, thank you very much, Pete. So it looks like we have about 20 minutes left here. So I have a brief list of some questions, and if you can just address them individually, that'd be fantastic. So we'll start with, we have a question here from Nate. His question was, Pete, is the industry growing? How fast? If I get this certification, will I be able to obtain a secure job in the U.S.?
That's a good question, Nate. And yes, the industry is growing, and it depends on so many factors. It depends on the price of oil, for instance. The fact that oil went up, that heating oil went up to almost $4 a gallon has helped the industry quite a bit in the north, where we burn a lot of heating oil. And that's why the New England Geothermal Professional Association was just formed this past year, and our Connecticut State Association up in the north, where there's heating, there's a growing demand and there's a lot more work for it. The fact that the government gives a 30% federal tax credit until 2016 means we're short of 4 more years where we're on a level playing field with some of the subsidies that are given to the oil industry. So I absolutely think that the work is there. It's best probably to hook up at the beginning with someone who is in this business, an established well driller or heating contractor, and go to work on their crew and get started. I just left a job this morning, and 3 men worked all day doing pipe fusion and connecting the 4 400-foot deep wells into the house. So the work is there. Is there a shortage of workers? Probably in the future there will be. I am bullish on it. And I think that since Forbes magazine came out yesterday and said that people should buy stock in the top 2 ground source heat pump manufacturers in our country, I think that the powers that be are behind geothermal too, and I would definitely make an investment in it, in education in it, and get that certification.
Great. Thanks, Pete. So our next question comes from Steve. Can you speak a bit about historic properties, especially those that are 100 and plus years old? Any experience, case studies, or thoughts?
Yes, Steve. We had a very good experience, and in the workshop I'll show you some pictures of the Historical Society Museum from the 1700s up in Hartford, Connecticut, and we installed geothermal there, and that's been saving them money. The benefit of geothermal compared to solar is that there are some aesthetic issues with putting photovoltaic panels on top of historic rooftops. Certainly in the historic district I live in, it would be frowned on, and I don't see many of them. Geothermal is the perfect solution. Geothermal involves digging a ditch for a day or two to connect to wells and covering it up. The lawn I'm looking at now looks exactly like it did a few years ago before I put the geothermal in. Geothermal is the way to handle the historic buildings that want the appearance to be the same afterwards as it is now. And as far as sealing them up so that we don't lose heat, that corresponds well with geothermal too. And we could talk about we do talk about energy efficiency in the workshop and insulation techniques and a little BPI as it's related to geothermal. So yes, I'm glad you're a fellow historical buff like I am, and geothermal is perfect for it.
Great. So we have a question from Paul. Paul asks, can an existing well that serves a house with potable water be used for a geothermal system?
Yes, Paul, it can, and it does. That's another set of ground source heating is the open loop. IGSPA trains in closed loop technology, where the water circulates, and the same water that was put into my system 4 or 5 years ago now is the same water that's in there now. It has a little propylene glycol biodegradable antifreeze in it, and it just keeps circulating that same water, getting warm and cool, warm and cool, warm and cool. For open source, there are some different characteristics. Long Island, for example, is a very sandy geology, and they actually can pump water up one well and reject it into another well, and that well can accept it. For areas in the country where you have ledge rock or clay soils and the ground cannot absorb all of the water, it pays to go with a closed loop system. But as we said in the slide, it all depends on the geology and the climate, and that's what you'll be trained to recognize. Now, open loop in a well does work, but if you're taking water out at 45 degrees and putting it back in at 39 degrees, you're going to be getting colder water out of your tap as a result. So there are some techniques to bleed off open loop systems. If you have a pond that you can draw a very good source from and take the heat out of the water and then return it to a separate recipient water body like a pond or an acceptable drain source, then that will increase your efficiency as well. The last thing to consider is water quality. We go through an example in the class where we show that at 3 gallons per ton times a 3-ton heat pump, that's 9 gallons per minute, over an hour and over 24 hours, you can run 5,000–6,000 gallons per day through the house. And we do not try to put any kind of water that has impurities in it that could cause a filtration problem to the owner in that case. So if your water is crystal clear and very pure and does not have any sediment or require any filtration, then yes, probably the existing well is a potential open source, open loop geothermal source for you. Thank you, Paul.
Great, Pete. So here we have a question from Megan. Is the training typically individual enrollment only, or can training be catered and brought to a company, college, or organization?
Yes, it's of course it's brought to companies and organizations all the time. Probably half of the workshops I've conducted have been to specific companies, and half have been open. In many cases, a college or university will sponsor one, and the local heating contractors and well drillers and engineers and students from the area will come in and take it. In other cases, the seminar would be sponsored at a specific company, but additional people are usually welcome to come in. And CleanEdison offers the program and can work with you to have it held at the class area of your choice, and possibly to open up to more candidates in your geographical area.
Great, thank you very much. So here we have a question from Barry. Barry asks, are there any prerequisites required to take this course?
Well, thank you, Barry. I pride myself on having about the top pass rate, and so I like to have mostly motivated candidates that are familiar with what's going on. But no, there's not a specific prerequisite. I think that in all cases we've offered it only to high school graduates as a minimal base. You have to know some basic math and concepts about heat transfer and electricity and how water circulates through pumps. It expects you as an installer to have a feel for what's right and wrong in here. So I would say that there's not specific requirements, but you have to be motivated to want to understand how geothermal works, and be motivated to understand how a building is heated and cooled, what happens in the ground, drainage characteristics, the environmental regulatory network that we work with. And so while there's not a specific degree, any prior experience is certainly going to help.
Fantastic. Thank you very much. So it looks like we have time for about 3 more here. To anyone whose question is outstanding and we didn't necessarily get to, I encourage you to forward your questions to CleanEdison, sales@cleanedison.com, or follow the link that is listed on this page here. We will make sure that all of your questions get answered and you're provided with all the information that you need. So moving forward, Pete, you mentioned that the training was 3 days long. How much of this time is spent in the field? This question comes from Nick.
None is in the field in the workshop. The workshops are held throughout the country. So CleanEdison, for example, took out the conference room of a hotel, and we went there and worked in the conference room. The main reason for the workshop is to pass the test and to go over the chapters and the material. You get hundreds of dollars worth of manuals as part of your tuition, and you mark up the manuals, and it's a study episode. You're in the classroom all day for at least 8 hours, keeping active and asking questions and participating, but also going through the material, going through sample questions, going back with a yellow highlighter into your manual and seeing the page and reference number on where the material is explained in the manual, so that during the test you can go right to the manual and read up on it and make sure that you're answering it correctly. So we emphasize the classroom here. We have a lot of pictures and videos of what's happening out in the field, but we do not go out and watch well drilling, for instance. But when you see the well drilling videos, you'll feel that you're there. The hands-on heat fusion training that's usually done outside is done in the classroom in a secure area where we have a proper electrical outlet and workshop table and so on. So that's kind of an outdoor experience that's inside. But no, there's 2 days of full PowerPoint, study guide, and manual reference, and at night you're expected to go home those 2 nights and study for a few hours. Then on the 3rd morning we go through heat fusion videos so you can see all the techniques. We do hands-on fusion together in groups small enough so that we can actually fuse the pipe together and see how it's done. We review for the test, we have lunch, and then we go through the NATE certification, the North American Technician Excellence Procedure, and you get an official 2-hour open book test in the proper setting. And I take those tests and we seal them up and we co-sign them and I mail them to Texas where they're graded for you. So this workshop is totally in the classroom. I also follow up with many of you. This afternoon I was working with someone that had taken the workshop months ago, and I'm helping him a little bit in a project, so I follow up with you. It doesn't end right here, and I give you a lot of websites and references so that you can continue your education. But no, there's not time in this to actually go out and see boreholes physically during the workshops. It's not a requirement, and that's expected to be done afterwards. Okay, thank you, Robert.
No problem, Pete. So it looks like we have one more question, and I think that I can take this one. The question comes from Dan, and it's, can these slides be viewed again? Yes, Dan, the slides can be viewed again. The recording of the webinar will be posted on YouTube by the end of the day today. The link to our YouTube page is www.youtube.com/CleanEdisonLLC. An email will also be sent out to everyone who registered for the webinar with the video embedded. So it looks like that's all the time we have today. I want to thank you all for joining us. I hope that all of the information was very clear. And if there are any outstanding questions, I do encourage you to visit our website or contact us at 888-513-3476. Thank you very much for attending, and have a great day.